Hey guys, in this section we're going to be covering the ideas of half-life and doubling time. Specifically, for an exponentially decaying function, so for an exponential function that's decreasing, the half-life is the amount of time it takes for the output quantity to be reduced by a factor of 1/2, right? The doubling time is kind of the parallel for that. That's if your function's growing, it's how long does it take to double what you initially started with. So let's start with an example to see how this is going to work. Let's take the example of caffeine. So now this is something that you can actually look up on Wikipedia. This is true. The half-life of caffeine is about 5 hours. So if I drink a cup of coffee at noon and I have 200 milligrams of caffeine, that's the amount I have in my bloodstream. How much am I going to have in my system at midnight, right? It's not going to all be gone. Right, so let's try to develop a little bit of intuition first. So 5 hours from now, so at 5 p.m., how much caffeine is going to be left from this coffee? Well, half of it's going to be left, right? 100 milligrams. Now, if I jump another 5 hours, so if I jump to 10 p.m., I don't lose another 100 milligrams. What I actually lose is half of what I have here, right? So I'm going to have 50 milligrams at that point. And so the question we want to answer in this problem is if I go to 12, how much am I going to have left? And we don't know. It's not a 5-hour jump, so we can't say the answer is going to be 25. So what we're going to have to do is come up with an equation for the amount of caffeine in my blood. And so we're going to use the exponential form here. We'll use P equals P0 e to the kt. And we know that P0 is 200, right? But how do we find the rest of this? And so just like our other problems, what we actually want to do is get an input-output pair, right? And so our input-output pair, we're going to use this 5, all right? So 5 hours from my initial time, how much am I going to have left? Well, I actually have this written down right here, right? I'm going to have 100 milligrams left. And so if I try to solve for this k, I can divide each side by 200, and I'll get 1/2. 100 over 200 is 1/2 equals e to the 5k. And now, if I come back up here, I can take the ln of each side, so I'll get the ln of 1/2 equals 5k ln e, because I was able to bring down that 5k, because the ln, this is going to turn into a 1, and I'll get k is equal to the ln of 1/2 over 5, which, if I type into my calculator, is about negative 0.139. All right, so now I have my equation. Now I know that the amount of caffeine in my blood is equal to 200 times e to the negative 0.139 t. Right? And so to solve for how much is left in my system at midnight, all I need to do is plug in p is equal to 12. So I'll plug in p is equal to 12, and I will type that into my calculator. To get that, I'll have about 37.89 milligrams of caffeine left in my blood at midnight, which is actually a decent amount. That's about the amount that's in a cup of black tea. And so what I want you to remember from this problem here is, first of all, a little bit of the intuition about half-life that we did here. But specifically, this is a problem where we take the half-life and we get an equation, right? And we get an equation. And so that's a skill that we're going to need to be able to be very comfortable with.